Okay, so this is section 4.4. All right, so for 87, the problem was cosecant negative 8 pi over 9, and this is out of 4.4, and it tells you to use your calculator to do it. And I don't know that we really ever talked about calculator steps, or if we did, I know we didn't do it more than once. If you think about it, isn't cosecant the reciprocal of sine? Okay, so what I'm going to really do in my calculator is I'm going to type in sine, and your calculator can handle the negative, negative angle. You just make sure you're hitting that negative at the bottom on the bottom row, not going and hitting the subtraction sign. And you're going to type it in, and you're going to get a number. And when you get that number, what you're going to do, you just leave it in your calculator, and there's a button. This is x to the minus 1 power. Let's think about what that's saying. That's saying 1 over x. So what this button does is it flips fractions. This is the flip fraction button. I actually sat here yesterday and did that. So when you, I didn't write the numbers down. So if you put in cosecant, make sure, again, you're in radians. Got to make sure, always be careful with your mode. You got to be in radians. Type in sine negative 8 over 9 pi. Hit enter and get the value, and then you're going to hit this button, and that'll get your cosecant value. So anytime you have one of those reciprocal functions, that's how you handle it in the calculator. Did any of you guys already figure that out? Page 294, section 4.4. It says here's a point on the terminal side of an angle in standard position. So if we were just to think about this for a minute, where's the point 724? It might, let's say this is out 7, that's at 24. We don't need to really draw a really complicated grid here. We're just trying to get the idea. So if my initial side's always on the x-axis, I'm talking about an angle there in the first quadrant, aren't I? So how am I going to solve this? How am I going to get the 6 trig values? If you think about it, if the point is up here, you're going, it works like the unit circle. You go over x and you go up y. So you've got a point. This point they're giving us is the x value and the y value. I can use that to draw a right triangle, basically. Even though it doesn't have a hypotenuse of 1, it would be a similar triangle to whatever's on the unit circle. And one of the things that they had you do in the previous section with numbers, I don't know if you remember that you had some kind of early on in 4.3, like 5 and 7, where they had you do all the trig values for 2 similar triangles, and you just were supposed to see they all came out the same. That's the idea here. Even though we're not going to have a hypotenuse of 1, I can think of this like I do on the unit circle. I can say, well, my x value is 7, so if I drew this here, the 7 would be like go out 7, right, to the x, and we would go up to 24. So basically I've got a little right triangle here to solve. And what can I use to figure out the third side? Yeah, you can use the Pythagorean theorem, and in this case, this is one of those triples that it's nice to remember. This is a 7, 24, 25. If you don't trust that, you can always use the Pythagorean theorem to verify it. So a lot of times they're trying to throw those at you in here just so you can do a little less work, now and then. So this is actually a triple, 7, 24, 25. And so what I'm going to do here is just go, okay, my angle, would my angle on the unit circle have been right here? I just kind of drew the triangle out to the side just so I could mess with it and have a bigger copy to work with. So here's my opposite side, here's my adjacent side, here's my hypotenuse, and I'm supposed to go find sine, cosine, tangent. Okay, so let's do sine. I'm going to make them in a, again, do I care about the angle? No, I don't care what the angle is right now. I just care about the values of those fractions of the sides over to each other, the actual trig values. So here's the values I want to find. In this lesson, you're going to do this a ton of times. They're going to ask the question in a lot of different ways, but they're really asking you, if you need to, draw a right triangle, find the third side of it, and then give me all the trig functions. So you're going to be using SOHCAHTOA a whole lot here. And again, if you need to write it down to help you remember, do. I'm just going to write it there so I can refer to it. The sine is the opposite over the hypotenuse. So if we look at the sine value, opposite is 24, hypotenuse is 25, so 24 over 25. If I make a mistake, y'all speak up. What would the cosecant be? 25. Yeah, we just flip it. That's why that button on the calculator is so handy. If I find a value, I can just flip it to get the reciprocal one. Now the cosine is adjacent over hypotenuse, so wouldn't that be 7 over 25? And then the secant, we would just flip that. Once I get my triangle set up, and I'm thinking SOHCAHTOA, it's kind of easy to flip through these really quickly, even though it's like, oh, there's 6 questions on one problem. Well, they should go pretty quickly. Opposite over adjacent should be what, 24 over 7 for tangent? And then I just got to flip it. And I'm done with that. Okay, so let's sketch a little. And again, you don't always have to do this. I just feel like it helps me understand what's really going on, because otherwise I'm just struggling. If I work in these problems, I'm really struggling to understand what I'm doing. Negative 410, let's say, and again, I don't have to be real exact with it, but that would be out on the negative direction on the x-axis and then maybe up here at 10, for instance, like that, right? So if I were to draw, here is I'm going to draw a line up to it. You know, really the angle they're talking about is this angle right here, but again, I can't solve that. That's not a right triangle, is it? But what it's interesting is if I were to draw a circle there, that point would end in the same place as if I took and made a little right triangle with the x-axis. Oh, that point right there really represents, I can think about the sides of that little right triangle. This is my reference angle. So what I really do is I really don't look at the angle that's really there, that they're asking me about, drawn in standard position. I care about the little triangle, we could call it the reference triangle. They usually don't call it that. They just say we use the reference angle. We use that little right triangle and the angle there that it makes. So let's think about this. Negative 4, wouldn't I go out this way 4 to the left if I were coming from the origin trying to graph that? So isn't that side 4? But since it's negative 4, I'm going to go ahead and write a negative there, okay? Because I did go minus 4 if I'm thinking about the coordinate plane. And then I go up 10, so isn't this side 10? Now it's kind of weird because there's a negative there, and we're going to talk about that. But if I wanted to, I could find the third side, the missing hypotenuse now, by using the Pythagorean theorem. Now, I could say negative 4 squared plus 10 squared is equal to my hypotenuse squared. If you wanted to, if you see that you could divide 2 out of those and reduce them, you could actually do the math with a 2 and a, oh, let's just not. You'd have to remember to do some extra work. Let's just not. Let's use the numbers there. You'd have to remember to do something to it, and I don't think that's a good thing. So our side would be, what, 16 plus 100? Is c squared, and when I square rooted both sides, it'd be that side is the square root of 116. You write that here. So the hypotenuse is the square root of 116. Now what they asked me for, first of all, I had to figure all that out. Really the trick to these problems is drawing the triangle where it is, figuring out the sides, you know, with whatever information they give you, figuring out the missing side of the right triangle you don't know, kind of like we did in geometry, except that we do have some negative, you know, numbers here. And when we square them, they get to be positive numbers. I can still figure out all the sides of my triangle. And once I got that, aren't the 6 trig functions pretty easy to do once you get the numbers? Now, I'm going to do it using this that I drew with the negatives in there and show you that I can get the values. And then I'm going to show you something else about maybe how you could do it a little quicker. My sine is opposite over hypotenuse, so that's going to be, 10 over the square root of 116, which I don't believe reduces very well. And if you look at the answer key and it does, just go ahead. Again, I'm going to try to stick to the new concepts, and if something reduces, and I should have reduced it, and you notice in the answer key it's reduced, just go ahead and do that. But my basic answer for sine is this. I did have to rationalize the denominator, okay? Now for the cosecant, it is, just flip that, and let me go back here to flip it though, so I don't have to undo a bunch of junk there. That would be the square root of 116 over 10. What would the cosine be? Here's your angle, right? In the adjacent side, this. So wouldn't it be negative 4 over the hypotenuse of square root of 116? I got to rationalize it. So it ends up being negative 4 square root of 116 over 116. For the secant, I'm just going to flip it, and again, I'm going to go back to the very beginning. I'm not going to take the rationalized thing. If I flip it, it's 116 over 4, and it's negative. And then for the tangent, it's opposite over adjacent. So it would be 10 over negative 4, right? And let me just reduce that to, what, negative 5/2. So on the cotangent, I'll go ahead and flip the negative 5/2 and get negative 2 over 5. All this is stuff. Now, what I could have done is forget about the negative altogether. I could have said, yeah, this is a triangle and it's got a length of 4 and a height of 10, and I could let my little memory device that we talked about take care of everything for me. Do you remember how we had all students take calculus? So now I know in each quadrant what's supposed to be positive. In the first quadrant, all my trig functions are positive, so I don't really have to think too hard. But like over here in the second quadrant, the only one that should have been positive was sine. So I could have just made this little triangle here and put, oh, out 4 this way and up 10 and kind of ignored the negative and just let the memory device take care of the sine for me. And I do that sometimes when I'm in a hurry, you know, when I'm like trying to work quickly. If you look at my values I got, my sine values were positive when I paid attention to the, you know, go negative 4 this way and up 10. They actually turned out like they were supposed to, didn't they? They're positive. Notice my cosine. Okay, so the only thing that's positive in this quadrant are sine, and then it's reciprocal, because when you flip a fraction, you're still going to have the sign, the negative on it. But as far as cosine and tangent, everything else is negative in the second quadrant. So let's check our values. Did my cosine turn out negative? Yeah. And of course the reciprocal would be negative. Did my tangent turn out negative? Yeah. And so did my cotangent. So what a lot of people do is they let the memory device take care of the negative, the sign for them. They just work with the numbers and they kind of ignore the sign. But on this one, you really do have to think I have to go over 4 and up 10 at least. So you could have drawn your triangle down here and had just 4 and 10 and then do your Pythagorean theorem and not worry about the sign, and it would have worked out as long as you remember that little memory device. Okay, the memory device is great for help for so many things, so I'm going to always refer to it just because it's a really helpful thing.